need to change where the drive should be controlled from. If we go to the CTL menu, we want to make sure the LAC parameter is set to 3. Then we want to set FR1 and 2 parameter to MDB. This will set the reference channels to Modbus mode. The CHCF parameter we want to set to separate. And the CD1 and 2 parameter we want to set to MDB2. This will set the command channels to Modbus mode. Now this is all the settings we need to do on the VFD to control it from the PLC. Sometimes we get some error while doing the Modbus settings. I did get this USF error. In most cases it's enough to just cut the power and turn it on again to reset it. Else you can check the manual for the VFD to find more detailed fault information. When the VFD says NST, it is ready to run. So let's jump over to TIA Portal and do some programming. In TIA Portal I will add my device with the RS485 communication card. I will simply add an unspecified device while being connected to the PLC from my laptop. It will detect the PLC with its components. If we click on the RS485 card, we can change its settings. But we want to stick with the default settings for this communication. If we click the PLC again, we want to check the box that says Permit Access with PUT-GET Communication from Remote Partner. We also want to go to System and Clock Memory and activate System Memory Bits and Clock Memory Bits. I will now go to my main block and do the programming. Under the communication processor map we can find the Modbus function blocks. I will add one COM load and one master block to the project. To the COM load block we want to add the first scan bit on the request input. And on the port input we choose our RS485 communication card. Baud rate we set to 9600, and parity to 2. To the last input we want to add the Modbus Masters data block that TIA Portal created for us. Before we program the master block we want to add a new programming rung, and make a counter that will continuously counting up and help the master block's request. To this Modbus master block we want to use it to write the frequency to the drive. To the request input we will set it to request when the counter we just made value is equal to 0. The Modbus address we want to set to 1 like we did on the VFD settings. Modbus mode we set to 1 since we want to write to the VFD. The data address to run the VFD is 48503. We get this value from adding 8502 to the Modbus holding register bit, which is 40001. The data length we want to set to 1. For the data pointer I will make a new data block. Here I will add one tag for writing frequency and one for writing the run commands. We also have to uncheck the optimized block access to give our tags a specific offset. I will now add the frequency write tag to the data pointer. Next I will add another Modbus master block that will control the run commands. To this Modbus master block we want to request when the counter block is at value 1. We give this block the same Modbus address, mode and data length. The data address for the run commands is 48502. We get this value from adding 8501 to the Modbus holding register bit 40001 like we did on the previous block. And to the data pointer we want to add the run tag from the data block we made. Next I will add 3 move blocks so we can move some command values to the run tag. I will add one tag to make the motor run forward. One to stop the motor. And one to enable the drive. To control the run direction, we have to look at a 16-bit binary to decimal converter table. In my case, I will just run the motor forward, so I will leave bit 11 as 0. But to let the command run, we need to add the value of operation enable 2, which is a true value on all 4 first bits. So to run forward, we take 15 plus 0, which is equal to 15. This means I will add the value 15 to the move block. If you would want it to run backwards, you need a true value on bit number 11. So to run it backwards, we would need to add 2048 plus 15 to the move block, which is equal to 2063. But I will keep it simple and just run forward. To the stop command, we use bit number 12. This means we add 4096 plus 15 to the move block, which is equal to 4111. And to the enable move block, I am gonna add the ready to switch on command. This is needed to let the VFD know it's ready to read the run the other commands. It required bit 1 and 2 to be true. So we take 4 plus 2, which is equal to 6. That's the programming we need to run the VFD. Let's go online and test it out. Now to test this out, we first need to trigger the enable bit to let the drive know it's ready to drive. Then we set the run command to let the VFD know it's ready to run. Now we can change the frequency as we like. And if I trigger the stop command, the motor will stop. Thank you for watching.